Hello, welcome to this course once again. In this unit, we are going to introduce you to the yarn parameters and the different characteristics of the yarns. Yarn selection for any specific application is based on many parameters. Yarn size is the primary consideration in achieving the functional and aesthetics requirements of the finished product. How to measure the thickness of the yarns? For companies, it is necessary to have information about the thickness of the yarns. This necessity is important not only for the final product, but also for the intermediate byproduct of the process. Yarns are soft materials, and for this reason can be measured with the conventional measurement of length tools. To obtain a definition of the measure of the yarn's thickness, the relation between the length and weight of the yarn is used. Yarn sizes are communicated through various numbers and numbering systems, which are derived by writing each unit, length and weight. It is important to know various numbering systems and their relationships to understand thread size specifications. All numbering systems used to indicate thread size are either fixed weight or fixed length systems. Systems under fixed length. The most used are text. Text is the weight in grams of 1000 meters. This number is the amount of grams that a hunk of 1000 meters weighs. To calculate the number, I can use this formula. In this formula, where N is the number of the yarn, W is the weight, L the length, in this case, K is the constant. In this case, for text system is 1000. Example, if I have a yarn and for a length of 100 meters, have a weight of 4 grams, and the constant in this case is this one, the number of the yarn is 40 ticks. And if I have another yarn, in this case with the same length, but in this case the weight is 8 grams, in this case the number of the yarn is 80 ticks. In fixed length systems or direct system, the yarn becomes thicker as the count number increases. Another example. With the same yarn, now with the linear system. I put the length, the weight, and in this case, the constant. This case for this system is 9000. The result is 118 linear. Systems under fixed weight. In this case, the most used are metric count, number of hunks of 1000 meters per kilo. For instance, the metric count, the number of the yarn, is the number of 1000 hunks in 1 kilo. Example, if I have a yarn and for length of 80 meters, it has a weight of 4 grams. In this case, its constant is 1, its metric count is 20. And if I have another yarn with the same length, but its weight is 2 grams, its metric count in this case is 40. In fixed weight systems, the yarn becomes thinner as the count number increases. English or cotton count. This case is the number of hands of 140 yards per pound. For instance, if I have a yarn and for it a length of 80 meters has a weight of 4 grams, in this case the constant is 0.59. The result, the number, in this case is 11.8 8. Resultant thread size. When more than one ply of yarn is twisted into a thread, finding the result size of the thread by considering all the plies become necessary. In fixed length system, resultant size is equal an individual yarn count multiplied by the number of plies. In fixed weight system, resultant size is equal an individual yarn count divided by the number of plies. A particular result size can be made with any number of plies. For instance, in this case, every plies are 40 ticks. The resultant size is 80 ticks. It's a yarn with 2 plies of 40 ticks. Another example, in this case, every plies are metric count 40. The resultant size is metric count 20. It's a yarn with 2 plies of metric number 40. To convert from one system to another, you can use this chart. For instance, to convert the text number in denier, you should multiply the text number per 9. There are a lot of more systems, but in this lesson I have presented the most used in the textile sector. Here you can see the photo references, and that's all. Thank you very much for your attention.